Dear audience, let me introduce my PhD topic, which is about the prosthodontic application of intraoral scanning systems, novel devices used in dentistry for impression taking. My name is Viktória Vitai, and as a dentist, my vision is to bring high-end digital prosthodontics available for all of my patients, and my mission is intraoral scanning system to the prosthodontic workflow. We already published two clinical studies. One of them is about a validation study of intraoral scanning systems, and the other one is about the tooth selection tool of intraoral scanners, because these devices are not just impression-taking machines, but they also have some special features involved in them. So both of my meta-analysis is connected to these topics. So in my first project, I wanted to give clear guidance to dentists to select the most accurate intraoral scanner for full arch impressions. We want to publish our manuscript in the Journal of Dentistry, which is a D1 journal. Some of the dental restorations can only be manufactured with CAD/CAM technology, which is computer-aided design, computer-aided manufacturing. And to use this kind of technology, we always need a three-dimensional file, which is usually an STL file. Intraoral scanners are devices which are available for direct digitalization of for arches to produce this kind of STL file. And we find many different intraoral scanners available in the market. Single tooth accuracy is clinically acceptable with them, but we find contradictory results with the full arch accuracy. Therefore, our question is that what is the accuracy with the different intraoral scanners when we are scanning full arch? And our hypothesis is that none of the scans made with the intraoral scanners are different from the reference STL files. In our population, we had 4 subgroups in full arch, and as index test, I have investigated 25 intraoral scanners when we compare them to the reference STL files. As an outcome, we measure the accuracy, which consists of precision and trueness, where precision shows us if the device can measure the same measurement again, and in trueness, we see if the device measures the same result as the original STL file. In the systematic search, we searched in 5 databases. After the study selection, finally I got 120 eligible articles in the systematic review part and 55 articles involved in the meta-analysis part. So in the subgroups, we had fully edentulous arches, also fully edentulous arches with implants, dentated arches, and partially edentulous arches with implants. You can see the results in the forest plots in the case of dentated models trueness, where we had 2 outcomes within the trueness part, which is the absolute mean deviation, and the RMS, which is root mean square deviation. In absolute mean deviation, usually the 2 measurements is measured in an absolute mean value. It's a mean difference, and in RMS they have x, y, z coordinates, so it gives more information about the 3-dimensional deviations. As you can see, more articles use the absolute mean deviation value, but the newer ones now using the RMS values as well. As you can also see that some of the intraoral scanners are significantly different from the reference STL, but there are ones which are not significantly different, and we use the 150 micrometer values for showing us the clinically acceptable ranges. Similar results are visible in the precision part with the dentated models. Also, there are no big differences between the scanners in this field, and we always find bigger differences in RMS because they have higher values in micrometers. As a result, in the edentulous cases, you can see a network plot showing the direct and the indirect connections between the reference and the intraoral scanners, and also a rankogram where the values showing us the order of the scanners within this subgroup. With the lighter the color is, the better the scanner is in this group. And now we have bigger differences between the scanners. Also in the edentulous implanted models, the difference is growing. And what was interesting in the mixed group, that all of the intraoral scanners are significantly different from the reference, but they are mostly within the clinically acceptable range. I have made a cumulative ranking because not just trueness itself, but also the precision is a very important factor in accuracy. So I summarized both rankings, and now you can see a ranking in the dentated models and also in the edentulous arch, and of course in the implanted arches as well. In this table, I summarized all scanners with the green color, which were under the clinically acceptable 150 micrometer range, and with red, which were out of this range. And you can see that there were some scanners which had great accuracy in all arches, but some of them were very bad at almost all arches. And it is another factor, but there are scanners where we won't get enough data about the arches. So in this case, we need more information about them. According to the model types, we can give indication for use for dentists. So in this case, we can suggest scanners for orthodontics, for implantology, for the denture workflow, and for the prosthodontic workflows as well. Thus, for conclusion, we can say that we found, in some cases, significant differences between the intraoral scanners and between the reference. And in the implication, we found, for example, that ZFX Intrascan is not recommended for the use for full-arch scanning, and there are available scanners in the market which can be good within the 150 micrometer range. And as for research, it is important to do more studies which are multi-arm clinical trials with a standardized reporting protocol. And as for strengths and limitations, we have indirect and direct comparison. Therefore, the evidence of the practical applicability is higher. And unfortunately, we don't have enough data about all intraoral scanners. And mostly, articles showed models and not patients. And in the second topic, it is connected to the tooth shade selection of intraoral scanners. Because 65% of the dental restorations which should be remade is because of the bad shade. Therefore, new digital methods were introduced in the market to reduce this highly objective method. And intraoral scanners has a new feature of this tooth shade selection. Therefore, our question is that what is the accuracy of the shade selection with intraoral scanners? And our hypothesis is that there is no significant difference between shade selection with the intraoral scanners when we compare them to spectrophotometers or colorimeters. So we compare the shade selection with intraoral scanner, and the reference standard will be spectrophotometer and colorimeter. And we also want to find the outcome, the accuracy, and the repeatability of the scanners. And if they are good enough, then we can say that they are objective and accurate time-effective shade selection methods that can be used for comprehensive case documentation. And in this second project, I'm doing the data extraction part. And I want to finish both of my meta-analysis in the end of summer. And I want to thank you for your attention with my quote, which is life is a board game where you have to learn the rules while you are playing the game. And of course, hope is not a strategy for that. So thank you very much.
You said that you, in your first project, you used some of the articles used models and others human subjects, but you said that more than 50 articles were eligible in the quantitative analysis. Wouldn't it be possible to conduct a subgroup analysis regarding only human subjects?
Yes, thank you for your question. Mostly the articles use models and not patients, and this is a limitation because we usually use these scanners not extraorally but intraorally, where we have saliva and many other factors that can influence also the accuracy, and this can also cause bias because maybe it is very easy to handle a model in my hand, and it is easy to scan it, but in real life, when the patient has blood and saliva inside the oral cavity, it is very hard to scan the teeth as well. So this is a problem that maybe those works, those restorations, what we do in real life, maybe they won't be as good as what we can do with the models extraorally.
Could you suggest a scanner for the conservative dentistry department?
Mostly in conservative dentistry, they don't really use full arch restorations because mostly for the rehabilitation they use inlays, onlays, and crowns, for example, or veneers. So these are single restorations. So in this case, I would suggest for the single accuracy more than the full arch. But of course, if somebody wants to do full arch cases and full arch restorations, in this case, mostly they meet dentated arches. So in this case, I would suggest from the dentated good accuracy part, yes.